Welcome back to the Punny Math Teacher. Today's expectations, remember to use this video twice its length. So I'll try to shoot for 10 to 15 minutes. So make sure you're using 20 to 30 minutes to watch it, pause it, take notes, answer questions, do the comprehension activities at the end, and just make sure that you've learned it and find extra resources at my website below. All right, today's objective and for the next episode as well will be to solve equations. Today we're focusing on one-step and two-step, and we'll do multi-step and then also do variables on both sides. So actually it's for 3 videos. And then at the end we have comprehension questions. So I'm going to minimize this and pull up our notes. So solving one- and two-step equations, it'll be page 8, so make sure that is labeled in your notes and I'll head it up. All right. Actually, I'm going to change color. I'm going to do blue and green. Alright, so we are going to solve one-step equations originally, and we'll have a bonus two-step at the end, and you'll see how they're really similar. So knowing how to do a one-step equation really solidly will help you with two-step equations, and that will help you then with multi-step equations. Alright, so we're going to start with x plus 3 equals 12. And I want you to think of this as being on a balance scale. Remember those balance scales with the 2 buckets in elementary school, and you put the little cubes or different weights in each side to see what would make it balanced. So it's on a fulcrum. That's going to balance it and go back and forth. It's like a teeter-totter. And we're going to label this as a balanced equation. And notice equation is really key, why we call it an equation. It equals, there's an equals sign. So x plus 3, whatever this is, whatever x is, if you add 3 onto it, that is the exact same as 12. They are equal values. That's why it's balanced. And we're going to call x our algebraic term. So going over some vocabulary, the invisible 1 is in front of this x. You can draw it if you want. You don't have to. That 1 is your coefficient. X is the variable, but 1x is a whole algebraic term. 3 is a constant because it has no variable. X plus 3 is an algebraic expression, and this whole thing is an algebraic equation, or just equation. Technically, like 1 plus 2 equals 3, that's an equation, but because we have an algebraic term, it's an algebraic equation, we're not going to deal with 1 plus 2 equals 3. We're going to deal with unknowns because we're going to solve for the unknown. So our goal is to get the x by itself. The fancy word for this is isolate. I can spell isolate. There we go. Isolate the variable. So it could be x. In this case, it is x, but it could be y, it could be w, it could be a question mark, it could be whatever we use to stand in the place of the unknown. We don't know the answer, so we're going to have a placeholder there. The placeholder can't be a number because that always already represents something, so it has to be something different. We use letters for that. You also can use Greek letters for that when we run out of the A through Z alphabet, but our goal is to isolate or get that variable by itself. So we need to get rid of the 3. That's the thing that's interfering with us right now, is that 3. I just want the x by itself. I don't want that 3 with it. So I'm going to rewrite my equation so I can show my work. Now, make sure you rewrite it correctly. That's actually a big thing in math. People look at the textbook and then go write it on their paper and they write the wrong number. So make sure you're actually looking and you're not doing a weird transposition error where you're putting the wrong number or you're switching them. That's actually a really big reason why people get problems wrong, is because they just don't look at it or double check to make sure they wrote it correctly. Okay, so x plus 3 equals 12. Now I want to get rid of this 3. It'd be really nice if I had an x plus 0. That would just be x, right? Because if you add a 0 to anything, it's just what you had before. So how can I make a positive 3 turn into a 0? If I'm at positive 3 on my number line, I'm going to go backwards or left 3. So I'm actually going to be subtracting 3. Now, if you take 3 grams out of one side of your balance, being your balance, your scale, you have to take 3 away from the other side, 3 grams on the right side. So I have to subtract 3 from both sides to maintain the balance of the seesaw. Okay? And 3 minus 3 makes 0. I'm going to cross them off. If it makes 0, then that's your check step in between while doing your work. So it's a really good thing. I'll have x, 12 minus 3. They're both constants, so they're like terms. 12 minus 3 equals 9, so x equals 9. And my goal is that this makes 0. If it doesn't make 0, I know I did the wrong step. It has to make 0 with it doing addition and subtraction. And we're going to see multiplication in a sec too. Well, maybe like 2 minutes. Alright, and then I can actually check my work too, which is awesome with equations. You can always get these right because you can always check and know if you are correct or not. So to check it, 9 has to be true. 9 has to make sense. So if I have 9 plus 3, 12, make that a 12, and put a question mark over the equal sign because I don't know they equal each other. Does 9 plus 3 equal the value of 12? Yes, okay. Check step done, all right? It's still balanced. I can draw it on that fulcrum, and I know it's not going to teeter or totter any direction. If I put 10, it would have teetered over to the left-hand side as being weighed more. If I had put 2, it would have tottered to the right-hand side because it would have been more on the 12 instead of the 2 plus 3. All right, so we did those. We're going to have 5 examples next. So we're going to do a box of 4, and then we'll have a bonus one at the bottom. Okay, so draw a 4 box, 4 corners, and we're going to have a bonus problem at the bottom. So we're going to start with x minus 5 equals 11. 11? There we go. So it's on a fulcrum, it's being balanced right now, and I want that x isolated. So I don't like that negative 5 right there. Remember, it's a negative. I'm subtracting a positive 5 or I'm adding a negative. Think of it as a negative, and that'll help us because if we're to the left 5, we're going to have to come right 5. I'm going to have to add 5 to both sides to make this go to 0. Negative 5 plus 5, 0. I can cross it off. I know I'm good. X equals 16. Check step. I'll use pen. Why not? Check step. So I'm going to box this because boxing is awesome. Check step. So 16 minus 5 does, there's a question mark. Question mark. Does that equal 11? 16 minus 5. Yes, that equals 11. Check. Done. Okay, I know I'm right. Next example. This one. Does this one have multiplication or division? Trick question. You could actually make the case that multiplication is division and division is multiplication, but we're looking at numerators and denominators. So right now I have 3. If you want to put this over 1, you can. So I'm multiplying the x by 3 and then dividing it by 1 if you want that invisible 1 to be there. In order to multiply by 3, how do I undo that? I'm going to divide by 3. And then instead of dividing by 1, I'm going to multiply by 1. Notice that this is the same as dividing by 3. It's also the same, dividing by 3 is the same as multiplying by the reciprocal, which is 1/3. So you've seen this before with fractions a lot. And then I was going to say something else with this. I don't remember what I was going to say. All right. We'll see. There's so many more observations you could do with this and why it's 1/3. So you could just put a fraction bar, put 3 on the bottom. That would have worked in the denominator. Or you can multiply by 1/3. And now 3 divided by 3 is 1. 1 divided by 1 is 1. Notice that everything over here turned into 1. And that's what I was going to say. Was for addition and subtraction, your goal is to make 0. Because you can do 3 plus 0 and you end up with the original of 3. For multiplication and division, you can do, I'll put it over here, you can do like 6 divided by 1, that's still 6. You could do 6 multiplied by 1, that's still 6. These are called the identities. So the additive identity is 0. I can add it and I'm still there at 3. It hasn't changed the value. The multiplicative identity is 1. I can still multiply by 1 or divide by 1, and I'm still going to end up with the original value that I had. It's not going to change it. So our goal here is to make this 1 with multiplication and division. Addition and subtraction is to make 0. You're making the identity, the additive identity or the multiplicative identity. I'm going to actually write those. Use pen. So you had the additive identity and the multiplicative identity. All right, and if you want, go Google those terms. You're going to find so many more resources if you Google those terms. All right, so those made 1, so I'm left with just x. If you want to put the 1 in front, you're welcome to as a coefficient. It's still there, it's just invisible typically. And then 15 divided by 3 is 5, so 1x equals 5. And again, for the check step, I could plug this in or substitute it in as a better word. Put that question mark. Is 3 multiplied by 15 the same as 3 multiplied by 5 the same as 15? It is, so I'm good to go. All right, 2 more examples. So I want you to pause the video after we write them and try them on your own. Do it in pencil, that way you can always go back and rewrite it. All right, so this one is 2/3 multiplied by x, or you could rewrite it as 2 multiplied by x and then divide by 3. Either way, we're going to be multiplying by the reciprocal. Whenever you see multiplication or division, think reciprocal. If you don't see a denominator, put the 1. That way you have that placeholder there for you to think about. 3 divided by 3 makes 1. 2 divided by 2 makes 1. If that did not make 1, we know we're in a world of hurt. We did something wrong. So we have to make sure that it equals 1. 6 divided by 3 is 2. 2 times 2 is 4. X equals 4. Do the check step. Write it on your own. What is the check step? Could you do that? So if I have 2/3 multiplied by 4 equals question mark 6. 2 times 4 is 8. What? How did we get that wrong? Okay, so I multiplied. Oh, 2/3. What did I do? Okay, 2/3 of x. That's 3. Oh, aha! I found my error. That I did not multiply by the same thing on both sides, did I? Nope. Okay, here comes a new marker. This was 2/3. I don't want 2/3. I want 3/2. Now 6 divided by 2 makes 3. So that's a 3. 3 times 3 is 9. This should be a 9. And that's why we have a check step. So this should be 9. Now we have 18 divided by 3 is 6. Now we're good. And that's why you have a check step. All right, last one before our bonus. We're going to have, instead of dividing by 4, I'm going to multiply by 4. In this case, I didn't do an over 1. You could if you want for the denominator and the 1. But if you see it's just a straight up division of 4, well, now just multiply straight up by 4. 4 divided by 4 makes 1, our multiplicative identity. And 6 multiplied by 4 is 24. We do the check step. And you can do the check step in your head, too, if you want. So substitute in 24. 24 divided by 4 is 6, so we know we're good. All right? Bonus time! And this one's... Hey, it's actually a good number. I just made it up. All right, 2x plus 3 equals 15. Now, I want to do something different. And I know we're running short on time here. But I want to do something different. Write a do and undo table. So imagine that we just were given the expression 2x plus 3, and I told you x equaled 4. All right, just imagine that. So if x equals 4, and I told you to find the value of this expression, you would take 2. You would substitute in the 4. You'd add 3. 2 multiplied by 4 is 8. 8 plus 3 is 11. So this is just using order of operations to simplify while plugging something in. What did we do first to this 4? When I substituted it in, what did I do first? I multiplied it by 2. So that's my first do, is I would have multiplied it by 2. After I multiplied it by 2, what's my second do? I'm going to add it to 3. So that my do list is just a list of everything I'm doing in the order, if I substituted a variable in the order I would have done it in. Now to solve it, I need to undo all of that, but in a specific order. So instead of doing it in this order, I'm going to undo it backwards. So instead of multiplying by 2, I'm going to divide 2. Instead of adding 3, I'm going to subtract 3 because this will make 1. 2 divided by 2 is 1. 3 minus 3 is 0. Okay? But I'm going to undo it in backwards order. So I'm going to subtract 3 from both sides first. Bring down the 2x because nothing's changed with that. My 3 minus 3 made 0. 15 minus 3, they're both constants, so they're both like terms. 15 minus 3 makes 12. Now I'm on the next undo. I'm going to divide by 2. You could have also multiplied by a half. That would be the exact same thing. 2 divided by 2 makes 1. Notice as I'm crossing them out, they're disappearing from my equation. That's me checking. Did they equal 0? Do they equal 1? If they don't, then I know I'm doing something interesting. And then 12 divided by 2 is 6. So I'm not crossing these out because they don't make 1. They make 6 instead. All right? And now I could check this if I want. So I'm going to have 2 multiplied by 6 plus 3. Does that equal 15? 2 times 6 is 12. Plus 3 is 15. So I know I'm golden. And 6 is my answer. All right, that's your bonus for two-step. Make up your own two-step. And that's actually, ooh, that's a fun dance. Make up your own two-step. Okay, compare and contrast what's a balanced equation versus equation. Does imagining a scale help you? If it doesn't, what's something different you could try? And then create your own equation and challenge someone near you to solve it, but you may need to teach them first. All right, so we're a little past 15 minutes. Thank you for watching and having patience. Have a great day.